IPv4 subnetting tonight. We're going to go over some different things. It's going to be an introduction to subnetting. Our primary purpose is to get our basics under wraps, and then from there we're going to go into some more advanced techniques a little bit later on. But here in the beginning we're just going to talk about basics, understand the basic concepts behind subnetting, and what we need to do to start to allocate our IP addresses. So our objective for tonight is going to be to create a subnet from a given address space, and we'll provide that in our example. So at the end of this, we should be able to determine valid start and stop addresses, and also a valid subnet mask. We're going to understand what our network address and our host address are. Later on in the lesson, what we're going to do is we're going to be able to determine our CIDR format for our subnet. And then last, we're going to document, and we're going to talk about how we document our network design. So here are some assumptions that I have that you're already going to know, what some of the address attributes are, what a class A, B, and C network is, what an octet bit, and what binary numbers are. So here's our problem that we're going to talk about. You're a junior network engineer. You're working for XYZ company. Business has been doing very well. You've been tasked to come up with a network design to best allocate the 32 Class C networks that your company has purchased on the metro area network from your local provider. So what you want to do, first off, is you want to take a look at the possible subnets before you submit your design to the senior network engineer. It'll be a pretty common task that you would come up against in the workplace. So here's some of our basic information that we're going to need. Here's our address space that we have. 10.000 is our starting address. And then for simplicity's sake, we're going to say 10.032 is our ending address. But technically it's 31.255. Remember that our Class C network has a maximum of 256 addresses, so it's our last octet that we use. So the method, there's a couple different methods you can use. There's the binary method where we can go along through all the hard, fancy, nasty math that everybody don't like. Or there's a different approach. And I'm going to show you, and this is what I'm going to talk about. It's called the graphical approach. We're going to draw it out. We're going to kind of look at it visually as opposed to trying to do the math behind it. And for those of you that are interested, if you want to know the math, we can prove the math in a different class. So here's what we're going to have. So we have our address space. And we're going to apply a subnet. Well, to be valid or to be useful, it has to meet certain criteria, and we're going to discuss that a little bit later once we get these basic breaks down. So the address, we can assume that our address space is valid that we're talking about now. So our technique that we're going to use, first thing we want to do, we're going to draw our space out, which we've got here. We start at 0, we end down here at 32. So once we do that, we can now start. So what we want to do, the first step that we want to do, is we want to cut that thing in half. When we cut it in half, obviously we're going to be at dot 16. So now we've cut it in half. And we're going to keep doing that. So now I'm at dot 8. I'm going to do it again. 4, 2, 1. I've now broke it into the major binary divisions. This is getting, into the math section, so I'm going to kind of stop it there. We're going to concentrate on the graphical ruler here that we got. Kind of looks like an old school ruler that you've seen thousands of times before. Starting here with the dot 16, dot 8, dot 4, 2, 1, and if we notice, the dot 1 is actually a single Class C network. So we now have it broke apart. So now we've ended up to the end. We got all the rest of our addresses added on there. So let's move on to the next thing we're going to do is we're building out our graphical subnetting piece. Next thing we're going to do is we're going to start on our first Class C network up there. And we're going to add the network mask. This is one thing you will have to remember. That a network mask for a Class C network is 255.255.255.0. Always the same. Network address, and then our host portion. So now that we have that, we can write that in. And what that does is allows us to see how many hosts we have. So we know we have 256 hosts in a Class C network. So we have our network mask, and we have our host. How we populate the rest of the information. And this is when you're going larger than a Class C network. Later on we'll talk about what happens if you're going smaller than a Class C network. Generally speaking, not super common, but yes, you do see it every so often. So when we're going larger, the number of hosts double at each major division. And a major division is going to be each one of these tick marks. So if you see going up, that is a major division. We calculate the net mass by subtracting 1 from our net mask up there. So on our next one, we're going to have 254 in our third octet. And we double our host to 512. The remaining, we will double the previous amount we subtracted. So in this case, we had subtracted 1, so now we'll double it. We'll subtract 2 for the next one, which will give us a 252. We'll double our host, which would give us a 1024. And we're going to continue to do that. So since we subtracted 2, now we'll double it, we'll subtract 4. So now we're going to have a 248. We'll double our host, so we'll have a 2048. And then you see that pattern continues. We had 4, double it, we subtract 8. We had 8, we double it, we now subtract 16. So if you see, we added our network mask in. And we also know how many hosts that we have. So now we have it laid out. Those are our possible subnets that we could use. Now, we got to talk about how are we going to allocate them. Well, we could have 32 Class C networks. We could have 4 that have 2048 hosts. 1, 2, 3, 4. Or we could have half, and then we could have 16 Class Cs. We can bust it up as long as we use valid addresses, and it covers the full space. Important thing to remember, valid subnets will not have any intermediate division marks higher than the start and stop address of the space being subnetted. So in this case, here's our ruler. I just turned it on the side and stripped some of the information off of it. Started at 0. Obviously the first tick mark is a .1. It's a Class C network. That's good. We could also go to here. We can cover 2 Class C networks. That's good. We cannot subnet into 3 Class C networks. Why? Our rule says that our intermediate division marks cannot be higher. So our ruler here, if we try to go to 3, this is actually higher than our ending address.
Oh, okay.
So it's not valid. So like this one here, we have it's not valid. We're starting here, ending here. This is good, this is good, this is not good. This is not a valid subdivision or a subnet. Same thing here. We can't break it here. We can move it, we can break here, we can take half, we can take the whole. So, when we're using our ruler, the important thing to remember is the start and the stop have to be the longest 2 in our subnet. So if we remember before, this was 1, that's true. Here to here, that's true. Here to here, that's true. Here to here, that was true. Here to half, that was true. So now, our company's made some decisions. We get a little bit more information. The board of directors said, hey, we're going to grow, here's our plan. So your senior engineer passes you some more information, and he says, hey, here's what we're going to have in our network. This is what we need to allocate those IP addresses for. So now you have some idea of how you need to break it up. You have to accommodate those number of hosts. So we've got a call center, we've got a corporate headquarters, a distribution center on the south side, north side, west side, and then we got one out at the beaches they're planning for, but it's not quite ready yet, but we need to set aside some stuff for that future growth. So what we want to do, here's where we'll start to document what we're doing. What we have up there is we have our name, so we have our logical name, our site name. We have the number of hosts that is known right now. Then we're going to determine how many subnet hosts we need, what part of the subnet that we're going to use. Then we'll log our starting addresses, and then we'll also apply our subnet mask as well. We're going to reserve these 2 for a little bit later. When we talk a little bit later, we talk about CIDR format, we'll use them as well. What this chart does is allow you to document, and you have a quick chart that you can look at, and you can figure out addresses without doing a lot of digging. So the first thing we're going to determine is our call center. It's obviously our largest number of hosts, so it's going to take up our largest portion of our network. So we have 3,725 obviously the largest division, or the next largest division that can accommodate that, is 4,096. So when we do that, it's half our network. So to be valid, we can either take it on the front half, or we can take it on the back half, because our start and our stop are our largest two. It can't go somewhere in the middle like that. Start and stop. Intermediate lines are larger, so it cannot go in there. It will not work. So we'll go ahead and we'll take that off. We're just going to say we're going to use it on the front half of the network. So that gives me a starting address, 10.0.0.0. If we refer back to our ruler that we had done before, we can look at our subnet mask that we had figured out. We can put it on there, so it's .240. So what that does is this provisions this part of the network for the call center. Like I said, the last two columns we're going to kind of set aside. We'll talk about them later on. So let's move down to the next one. Corporate headquarters. 1675. So our next largest division that we need, 2048. Well, this one, we can put it in here, because it's going to take up a fourth of our network. Or we can put it in the back half. Either one. It could go there or there. Well, I'm going to just pack it back onto the call center. We're just going to keep everything nice and neat. So it's going to stay there. What it does, it now gives me my starting address. It starts where? Here. At .16, so I can fill that into my chart as well. Refer back to my ruler that we had already created. And so I get a subnet mask at 248. Do the same thing. Move down to the distribution center. We determine we have 1028 of our hosts that we need. Obviously, we're going to fill it in. It's equivalent to 1/8 of our network. We'll put it in there. Refer back to our chart. We know our starting address is .24, and our net mask is .252. Then the last thing, we now have our 4. Those are going to be Class Cs because we can use 256 hosts. So as I put one of those in, south side is going to come in, put it here on the end. Once again, all these are valid. It still follows my rule. No intermediate mark is higher than my start or stop. Here, we're going to start at 10.0.28, and then we'll finish the rest of them out as well. And as they go in, so we have south side, north side, west side, and beaches, and I have fully allocated my address space that I was given. And I can accommodate all my hosts. Everything is documented. I can look at my chart and know which network I'm on if I'm given a certain network address. Any questions so far?